Thanks so much for joining today. We're going to be talking about metabolic resilience, which is relatively a newer concept. It's something that we are unearthing, that Dr. Jasbi has recently provided a publication on that'll be coming out very, very soon. And this concept really just conveys the patients who are non-responders to treatment. These are the people that are very difficult to get into a health state. Or on the flip side, you can have metabolic resilience in a positive way. So you can have people that are healthy that have a quote unquote difficult time transforming into a disease state. So we're going to be talking about this topic from a scientific standpoint and discussing more of the paper that Dr. Jasbi recently introduced.
Thanks for having me, Micah. So as you mentioned, we have written a paper on metabolic resilience. We are really focusing on the temporal dynamics of metabolic resilience and various cellular responses using a omics and evolutionary perspective. This review paper is actually set to be submitted tomorrow. We were invited by an editor, Dr. Fabiano, of Trends in Metabolism and Trends in Endocrinology and Metabolism. So it's a very high impact journal, and we're quite pleased being invited to write a review paper on this very timely topic. And resilience is something that we are just sort of discussing and unpacking in the science. This is a concept that has come from really psychology and has been adapted to various disciplines, including the biomedical sciences as well as engineering even. And so it's a really great topic, and it is really adjacent to my favorite scientific topic to discuss, which is evolution. And I'm really happy with the paper that we've written. We really go through and sort of unpack what resilience is. We discuss the temporal dynamics of metabolomic and transcriptomic responses. We talk about what is a immediate response and what those immediate responses are meant to do in terms of survival, and then the sort of long-term adjustments that happen as a result of chronic DNA modulation. And we compare some timescales and natures of change. And then we finally really wrap up the paper with a discussion of ecology and evolution. Once you understand resilience and how different organisms may respond similarly or differently under various stress conditions, now you get to understand how do we conserve corals in our oceans, which we wrote a paper about earlier in this year, and looking at insulin signaling of corals. So if you can understand how resilient or flexible these metabolic networks are in various species in response to different stressors, we can actually go ahead and support species adaptation and ecosystem stability by making some very targeted interventions available.
So if you had to describe metabolic resilience from a, let's say, clinical kind of simple perspective, and then we'll increasingly unpack this, who are the type of people that might have metabolic resilience, and then what is the significance of that? How might that in the future, I know we're still getting deep into the science from understanding this topic more, but what do you think it will potentially, how will it transform the way a clinician approaches a patient?
Right. So let's say in terms of an individual who comes from ancestry that lived in very cold climates, this individual may have a very high rate of expressing uncoupling proteins in the mitochondria. As such, this means that an individual will essentially dissipate protons across the mitochondrial membrane, and instead of generating ATP, this person will generate heat. Now that's great if you live in let's say, a very cold climate. Now, if you move out of this climate and you're generating all this heat from your food and you're metabolizing your food at a very high rate, but you're not gaining weight and your energy levels are very low, right? This is common in individuals that have these uncoupling proteins. They report chronic fatigue, and they also have very high metabolism. These are the people who can eat a ton and they stay very skinny, usually. They come from this sort of descendants. They're descendants of this ancestry, and these individuals have a very inefficient mitochondrial membrane transport system. So their electron transport chain, where these protein systems are embedded in the membranes near each other, these uncouple, and so the generation of ATP is much less efficient. The generation of heat is much more significant. So this individual may come to a clinician and say that I am suffering from persistent fatigue. And the clinician may say, okay, what we need to do is put you on, CoQ10, we're going to put you on alpha lipoic acid, and we're also going to put you on a high dose of citrate. Maybe that's a regular supplemental stack, mitochondrial stack for that physician. And that's not unheard of to put these three together. The issue is that only one out of those three therapies are going to actually improve this person, right? The CoQ10 will help with mitochondrial efficiency in the electron transport chain, but feeding this person more citrate is not necessarily going to in the TCA cycle is not going to affect the ETC very much. Or putting them on alpha lipoic acid will reduce the oxidative burden on the mitochondria, and that'll have some other benefits, and it will also increase fatty acid beta oxidation, which will have some sort of marginalized returns in ATP. But ultimately, you're not addressing the inefficiency of that mitochondrial membrane, of that electron transport chain. You're looking at an upstream process. So a clinician should understand really the evolutionary background of their patients, and understand that some people have resiliency and adaptations that are hardwired into their metabolism that really need to be adapted and overcome.
So as you're getting into the science and you're starting to unpack this more, well, it sounds very individualized. So it sounds like a pretty complex topic, because metabolic resilience can assumedly take the form of many different factors. So how do you, from a biological measurement standpoint or quantification, understand metabolic resilience?
Yeah, so from a quantification standpoint, if we want to quantify this, obviously we can take a look at things like immunity, right? Some people have enhanced immunity and are much less susceptible to having any sort of complications, even in response to very severe interruptions like sepsis, right? Some people have very good responses. They have a very good biphasic response to sepsis, really a powerful and mitigating metabolism, immunity. So we can do that by measuring really important pro-inflammatory pathways, looking at the levels of pro-inflammatory cytokines, looking at metabolites and analytes that are involved in NF-kappa beta signaling and STAT3 signaling. We can look at an individual's thyroid hormone levels and insulin resistance. So this is something that, again, in the context of sepsis, is really important. So as sepsis really progresses, the body actually shifts into a hypometabolic state. It reduces energy expenditure, conserves resources, and this is, again, mediated by levels of thyroid hormone levels and insulin resistance. So if an individual is insulin sensitive and has poor thyroid hormone metabolism, they are less likely to induce that hypometabolic state to reduce energy expenditure and conserve resources, and are more likely, actually, when we stratify them in studies, these individuals are more likely to die of sepsis. And we already talked about, mitochondrial uncoupling. In the context of mitochondrial uncoupling, we can take a look at who is more or less likely to be one of these individuals by analyzing transcription factors, so measuring levels of things like PGC1 alpha, which is really involved in those uncoupling protein processes. So having a very high PGC1 alpha is more indicative of an individual who has this it's an adaptation. It's an adaptation that at one point helped this individual's ancestors survive. Now in the modern world, it's leading to chronic fatigue and usually some sort of malaise, both physical and psychological malaise can be associated with it. But at one point, it was necessary because this person would have died otherwise, right? And so this is the idea that you have certain environmental stressors. They affect the body in different ways. Irish descendants of the potato famine. They have the opposite of uncoupling proteins. They have incredibly conservative and frugal metabolic processes. They expend less energy. They secrete more ghrelin. They secrete less adiponectin. So what's happening is they're actually far more hungry. They have less satiety signals, so they eat more. But also their body has been engineered in such a way because of their ancestors' exposure to potato famine that they burn less calories doing the same thing. Their basal metabolic rate is significantly lower, and they're also hormonally they're wired to eat more. And be less sensitive, far less sensitive to the satiety cues that a full stomach will necessarily send to the brain via the vagus nerve, right? We also have key aspects of AMPK. AMPK is a activated protein kinase. It is involved in many energy stress responses. It's an energy sensor essentially, and it looks at the ratio of AMP to ATP. And so when it senses that the body is low in ATP given this ratio, it's a biosensor, it inhibits energy producing, it promotes energy producing pathways, and it inhibits energy consuming pathways, and it allows for that person to cope with acute stress. So we have these very acute responses and very chronic responses, and for both of them, Micah, there are clinically proven ways to look at this individual and see what phase of the response they're in, how responsive they are, and try to quantify their degree of resilience.
And so why is this perspective, do you think, going to be helpful? Why do you think it's going to be helpful to understand the biology of somebody through the lens of metabolic resilience?
Right. Well, that really goes back to how innate metabolic resilience is. What do I mean by that? Metabolic resilience is the opposite of adaptability, and it is the opposite of adaptability in a very important way. It's based to evolution, right? It's going to help us in the context of metabolic health and our ability to adapt to stressors and homeostasis and recover from disruptions. That's what we have in the modern world. Is you have stressors, and then you have stressors that are trying to affect our metabolic health. We have a body that's trying to adapt, maintain homeostasis as best as it can. The body is very clever and exceptional in this regard, and then recover from disruptions, both either while those disruptions are still present or when they've been removed. And it's pivotal to our concept of health and disease because it really encapsulates how well an individual can essentially bounce back from these metabolic challenges. Understanding resilience provides a really comprehensive view of an individual's health beyond these static measurements. So beyond where you're at right now, it provides information on this modifying variable, resilience, that can help us better chart your projected trajectory into the future. It's essential for understanding how the body responds to various stressors. So dietary changes, physical activity, illness, environmental factors. At Therium, when we prescribe a digital twinning protocol, we are doing so currently really without knowledge of how resilient this individual's metabolic system is. So an example might be that, a resilient individual might experience a temporary spike in blood sugar after consuming a very high carb meal, but will quickly return to normal levels. In contrast, someone with low resilience may have prolonged elevated blood sugar levels, which will really indicate a higher risk for diabetes. So we don't have that data right now, right? If in the future we combined our metabolic panels and our survey information with maybe data from continuous glucose monitors and some data from the individuals on what's their glycemic index of their meals that's reported in their surveys, we would be able to more accurately predict risk of diabetes further out into the future. Same thing goes for the ability to maintain homeostasis, which is what the body is always trying to do is to find that set point, really. So during intense exercise, somebody who has a resilient metabolism can efficiently manage energy production and utilization. They can prevent fatigue and they can maintain that level of performance. And so when we are looking at the athletes that test with us, having a gauge of that resilience, again, by measuring many of the pathways underlying resilience, like NRF2, HIF1 alpha, FOXO protein, which is a forkhead protein. This is really going to be a crucial step for helping these individuals continuously engage in regular physical activity and optimize their performance. Or recovery from disruptions, right? I came back from our recent business trip to Denver, and I was sick for 2.5 days, let's say 3 days, okay? My wife, who got sick 2 days after me, is still having a throat ache today. So after a period of illness, a resilient person can restore normal metabolic function faster, which actually, when we think about in terms of long-term sickness, the quicker you restore metabolic function and you're back to a healthy, normal state, the more significantly you reduce the risk of long-term complications. Right? So long-term complications are associated with how long your clinical course is. A longer clinical course or a longer prodromal course is significantly correlated with worse clinical outcomes. So to understand resilience, we may be able to induce quicker recovery in individuals following illness or other disruptions from metabolism. And in the context of illness and disease, we can improve their prognosis by understanding resilience, right? When we assess metabolic resilience through the AirStyle test, healthcare providers can identify individuals at risk for various conditions. We can look at diabetes, we can look at cardiovascular disease, we can look at metabolic syndrome and enable early interventions. Our goal now is to really theorize what resilience is and try to develop better tools at measuring it, so that way when we report this information to healthcare providers, they have essentially more data points that can really look at things like lipid metabolism, personalized dietary and lifestyle recommendations, and how those are going to be interacting with this core concept of resilience that is unique basically to every individual, and how they can use that information to improve their lipid handling or their overall metabolic health. And with traditional tests, they might show normal blood glucose levels at a single point, but a resilience assessment reveals how glucose levels fluctuate and recover. They are much more dynamic and therefore offer deeper insights into glucose metabolism efficiency.
So as I understand it, this is allowing for deeper targeting, but also deeper prognosis and potentially diagnostics. So in the concept of digital twinning, we're creating a digital replica of the person based off their biological data, right? And so that is inherently going to be limited by the capability of the data at hand. So when we make a replica of this person based on their biological data, we can run simulations of different interventions, and then we can project how those interventions are going to affect this person. And the way we do it at Theriome is we run over 1,300 different interventions. So those are cataloged. We mine the literature to understand their weight, their significance, etc. And then we simulate each one of those 1,000 times. And so you get this protocol that's produced at the end based on what we believe is going to get this person the quickest results. Now, when you add in metabolic resilience, perhaps they have the same, it's going to affect the protocol, but just assume that they had the same protocol. So it's the CoQ10, the citrate, and the magnesium, or whatever you said. But somebody with high metabolic resilience, now we might extrapolate that person could take 4 months to get the results, as opposed to somebody, that is very accepting of it might take 2 months. So not only are we getting more granularity about the time frames for positive results, but you're also seeing, as you mentioned, potential diabetes or different things. So this is really about targeting and understanding the future trajectory of this person, as I understand.
Exactly, Micah. You said it perfectly and way better than I could as a scientist. You really distilled that down. In the context of our digital twinning, what this means for our customers is that as we learn more about resilience and as we increase our research and our data collection efforts, we will be able to more acutely and accurately chart this person's predicted trajectory through time, given this inclusion of a resilience variable in our models. So being able to understand if this person is metabolically resilient, should we test them later? Should we give them more of the intervention? So if somebody is really resistant to change, if, for instance, their gut microbiome is heavily resistant, does that mean that instead of offering them 10 colony-forming units of a multi-strain probiotic with this much fiber, should we offer them 50 with double the fiber? How much fiber? What's the dosage? Or should we just give them maybe 30 CFUs for 6 months instead of 3? These bring up a lot of, clinically, right? Philosophically, we can get into the evolutionary meaning of this, and it's very vast. But clinically, at a pragmatic level, this relates to prognosis, patient stratification, treatment, improved outcomes, and really understanding personalization through this concept of resilience has shown lots of promise in the literature for leading to improved outcomes and prognosis in clinical populations.
How does this compare to metabolic flux? So maybe define out in a sentence or two metabolic flux, define out in a sentence or two metabolic resilience, and then just explain the difference between these two things.
Right, so that's a really good question. So metabolic flux has to do with the literal movement of metabolites or proteins, usually metabolites when we talk about metabolic flux, in systems, okay? And resilience has to do with the number of movement of that flux. So for instance, we talked about like the metabolism of a high glucose meal, and some people will have greater flux in that instance, right? So you have a very high carb meal, somebody who's more resilient and is more probable that they'll come back to normal blood glucose levels even after a high glycemic load meal. This individual is going to have a higher flux. They're going to go through oxidative phosphorylation and insulin signaling much, much higher, right? They're going to translocate. The insulin receptor will bind. It will induce the expression and translocation of GLUT receptors.
Can I interrupt real quick? So yeah. I just thought to myself that metabolic resilience is really your capacity to return to homeostasis. And that's what you are underscoring here, it seems to me.
Exactly. So in some instances, it may mean that you have a higher flux. If you're more resilient, you may have a higher flux, higher movement of metabolites compared to a non-resilient individual. In some instances, or in the instance of insulin signaling, that means that if I'm very resilient, I have a high carb meal, instantly my insulin receptors are activated, that insulin signal goes down to the nuclear DNA, it expresses the rapid generation of these GLUT4 proteins. These GLUT translocators go and get embedded into the membrane, and they suck in glucose from the systemic blood. They reduce my blood glucose levels and bring me back into homeostasis very quickly. As opposed to an individual that has low flux, that cascade of metabolite signaling happens much slower. The genomic response is much slower, and ultimately bringing blood glucose down is much slower. Now, in a context of individuals who are highly resilient in the face of, let's say, some sort of environmental contaminant, let's say road asphalt. Road construction always gives off bitumen. Bitumen is a very highly volatile, caustic, and detrimental molecule to our health. So bitumen comes, and we both breathe the same amount of bitumen. Micah, you're more resilient than I am. We both breathe the same amount of bitumen on our commute to work. You are going to have, in this instance, most likely, a slower flux of these metabolites, right? So you're going to have a slower response. You're going to metabolize it slower. You're going to create less toxic byproducts of bitumen metabolism because your metabolism of bitumen is slower. You're going to maybe create some other compensatory mechanisms like antioxidant defenses that might be quicker. So compared to me, let's say in this scenario, I have a low resilience metric. In that case, I'm going to metabolize bitumen quickly. I'm going to produce all this toxic byproduct of bitumen metabolism, and my antioxidant defenses might be slower to be conscripted into the service of defending my body against this bitumen. So some fluxes may be slower, some flux may be faster. Flux is a process that serves resilience, right? Resilience is this concept, this still unfortunately vague concept of what does it mean really in certain instances. But flux is the movement of metabolites. Especially when we talk about metabolic flux, we're talking about the movement of these small molecules through pathways. And in some instances, a higher flux may be related to higher resilience. In other instances, a lower flux may be related to higher resilience. It really depends on the context.
So, do we anticipate, how long do you think it's going to take to understand this to the point that we can consolidate? Because it sounds like there's so many different variables that you can look at to understand metabolic resilience. And that means it has just you need a lot of data, right? And so how long do you think it'll take for us to get to the point that we can consolidate this into a score? But then there's also the question of, is it associated with a disease state or a health state?
Yeah, so it really matters. So I think for certain aspects of the omics sciences, we are currently there. Like, we have our upcoming microbiome kit coming to the market, and with that report, you will have resiliency metrics because we have a lot of data on gut composition. We know this pretty well. So this is one foray where the science has matured enough to offer some metric on resilience. And so we know that certain bacteria at certain levels will essentially predominate the gut. And it's very difficult to change the composition of the gut in those cases, right? So, if you have high lactobacillus, high, Bacteroides, these are the high ratios. We know that you're probably very resilient because these microbes are very kind of resistant to change. And we know that your composition is relatively healthy. We know nothing about diversity, but we know that your most likely beneficial bacteria are there, and you have good resilience. On the flip side, we have individuals that come with recurrent C. diff infections. So if you have C. difficile, Clostridium difficile, then you're going to have these really terrible gastrointestinal symptoms, usually diarrhea, nausea, weight loss, persistent. And in these individuals, they are not responsive to antibiotics. This person has become very resilient, right? And we may have a very tough time changing their microbial composition with just probiotics and fiber. We may have to go on some sort of gut cleanse. We may have to, put them on some sort of very natural laxatives. We may put them on water fasts. We may even recommend FMT, fecal microbiota transfer, in those cases where it is seen to be very difficult, and this individual has been suffering from C. diff for 4, 5, 6 months. It's not unusual. So they're resilient, and the body, the ecosystem, is going back to homeostasis. The problem is that the homeostasis it's going back to is the homeostasis that's preferred by that C. diff that's colonized the gut, not the homeostasis of the body. So your homeostasis is now in direct contrast to this gut homeostasis, and they're trying to duke it out and figure out, well, who's going to win. That happens a lot with the microbiota, where these bacteria, their idea and their set point for resilience is different than ours, and that's where a lot of the metabolic perturbations take place.
Here's the point I want to make to clinicians watching this, is that wouldn't it be nice to understand what is the minimum amount necessary in terms of treatment to get the patients to a certain outcome that's desired? So, for some people, if you understood their metabolic microbiome resilience, and it was associated with the disease state and very high, then that means you're going to have to put some back, your elbows into it, your back into it to get this person to the outcome that's desired. But that's really good to understand, because then you can frame it up for this person. You can frame up that, hey, This is what I'm seeing from your biological data. And what this means is this is going to take you a bit longer than the average person. This is going to require a bit more than the average person. And then your compliance will increase because they won't get 6 weeks, 8 weeks in and have some false promises of the outcomes that were anticipated, right? So your anticipation of the outcome becomes much more accurate. And on the flip side, if somebody has metabolic or microbiome resistance associated with a health state, maybe you don't need such an invasive protocol. Maybe you don't need to go into the amount of depth. So where I really see this fitting in is once we understand and can attribute resilience to health states, disease states, and have a score available for people, that we can really assist them in setting expectations, and not just setting expectations, but understanding of their biology so that you can create a better anticipation of what the outcome is going to be and how long it is going to take.
Exactly. Yeah, exactly. And metabolic resilience has not, we like to think, I'm resilient, that's good. Not so much. So in the context of evolution, metabolic resilience can be incredibly, incredibly detrimental. So let's say in an individual, in cases, and we have a figure that really describes this very well using butterflies in this upcoming paper. And metabolic resilience in the modern day has a different connotation, but let's say you're a butterfly in prehistoric times and you have stable stable...
It's a typical daydream for me.
Yeah, right. Typical daydream. I'm a butterfly in the prehistoric times. So you have, this constant ecological stability, and then, of course, this resilient butterfly doesn't change, and that's great. No pressure from the ecology. The environment is not putting any selective pressure on the organism. There's no need to adapt. But in individuals, let's say, where the shift has changed from ecology 1 to ecological niche 2, once that niche has changed, let's say because of decreased resources in the environment, those butterflies that are less resilient, right, and are more adaptable, they might, through successive generations, become smaller and smaller. They are adapting to their ecological niche by reducing their actual size and reducing their dependency on food resources or shelter, whatever the case may be. Because those resources have become depleted, they are reducing those size. Now, if I'm a resilient butterfly and my food resources have just been kind of cut in half, I'm going to probably die out. And I'm not going to pass on my genes to the next generation. In the context of predator-prey dynamics, which is very important to understand, when you have a shift in a new predator is introduced into your environment, maybe those butterflies that grew red spots on their wings as a deterrent to that prey, to that predator, those go on. They're very adaptable. They didn't need a whole lot of inducing, and in a few generations they developed these big bright red spots that ultimately deterred predators. The resilient butterflies didn't do so, and they die off, right? So metabolic resilience is very important to have if you're in a healthy state. If there is no changes in your environment, metabolic resilience is hey, all systems go, and we're going straight ahead with it. If you are in a disease state, or if there are ecological factors that are inducing some sort of selective pressure on you, being less resilient is actually beneficial. Maybe not in the short term, but in the context of you passing your genes on, and evolution, in the perspective of evolution, it's very beneficial to be more adaptable, more flexible, and less resilient.
Is metabolic resilience, or really any form of, I would imagine that there's not only microbiome, but there's proteomic, epigenetic, etc. I would imagine there's many forms of resilience that can be found. But is it similar to genetics, where you get what you get and you don't throw a fit? It's just something that you're stuck with, or can it be altered over time?
Yeah, it can be altered over time. And it can be altered by a few things that we know of. First of all, in our paper, we don't just talk about metabolites. We talk about all of these levels of, and in fact, when we look at most responses to stressors, there is usually the genome and the transcriptome are kind of the first ones to respond. They're very quick to respond in the sense that there's no change in the genome, but the expression of the genome changes very quickly, right? And then as we kind of wait a little bit longer, we see those expressions changing the proteome and then the metabolome. There are things we can do to increase our resilience or increase our flexibility in modern day. Those can range from things like hormetic stressors, right? Why do people do cold exposure? Why do people do sauna? These induce a very low level of chronic stress that ultimately improve the adaptability and functioning of metabolic networks. So, heat shock proteins, cold exposure, we have, compare us, orcas to alligators and toads, reptiles and amphibians, and you will see that 90% of the metabolic response to cold exposure is the exact same. Same genes, same proteins, same transcription factors, they're the same. However, there's a 10% difference in endothermic and ectothermic species like us and orcas and mammals in general and amphibians and reptiles that completely changes the outcome of the behavior. So in us, when we have cold exposure, what do? Brown adipose tissue activates, and we have a shivering response, right? We shiver in response to cold temperatures. We bring that muscle heat up. Ectothermic species, the ones who don't generate their heat, in response to cold exposure, they have a behavioral response. They go searching for heat. They need a source of heat. So 90% of everything that happens from the moment the cold exposure is sensed or the heat exposure is sensed, right? 90% of that metabolic response is the same between us and a toad. The difference is in that 10%. So most of our responses are conserved across species, evolutionarily speaking, but there's 10% difference that completely changes the outcome. Whereas if I'm hot, I will start to perspirate and cool myself off, but an ectothermic species, they might go seek the shade. I might also seek the shade. But there's a different metabolic response, but most of it is the same, right? When we look at like receptors and nuclear expression and proteomics and the metabolites, they're roughly the same.
Well, I think that you alluded to earlier microbiome resilience and the metabolic resilience we will be incorporating into the test. I'm not exactly sure on do you have an idea on time frame for that?
I think the microbiome resilience is ready to go.
Metabolomic.
Metabolomic resilience, far less so. Far less so. I would wager that in the next year or so, we will have some sort of metric on this, either a domain score or some sort of algorithm that we can use in our digital twinning at the very least. Metabolic resilience is really different because there's this great heterogeneity in metabolism between people. And two people who have very healthy states might have completely different metabolites and their levels and profiles. So it's not as sort of ubiquitous like the microbiome. We know that if people who have E. coli and C. diff are going to have some gastrointestinal problems, that's not really personalized. However, you can have people who have totally different rates of mitochondrial flux, and one have perfectly high, and both of them have perfectly high energy levels and no symptoms that are associated with mitochondrial exacerbation. One may have super low mitochondrial flux, one may have super high, but they're not experiencing any really different outcomes as far as self-report measures, or even when we look at a mitochondrial test through a muscle biopsy, they might be the same. So it's more heterogeneous, it's more varied. So we're going to have a more difficult time coming up with a concept and a means of measuring resilience in the metabolism.
But I'm pretty confident you'll come up with it. You guys are excellent researchers. You understand the big concepts, but also just all the in-depth analysis that's required, all the statistical relevance of things. And so I have no doubt that you guys will unearth something that can be really impactful in this way and give people a better understanding, like I said, to understand prognosis, to understand outcomes, length of outcomes, etc. But that brings me to another point about the microbiome test. And I have a pretty exciting announcement to make. So we are going to be rolling out our microbiome panel to the public, so to speak, so to medical providers, early next year, perhaps December of this year. However, we are currently doing a early launch with 5 more clinics, so we're only accepting 5 clinics at this time, and it's upon qualification. So what we found is that it's really helpful for us when we're launching these things to work with clinics that are really motivated in their career, really motivated to get outcomes, and are really intrigued by the concept of precision medicine and pushing the frontier in this, right? As you heard Dr. Jasbi talking about, this is new science that we're understanding that's allowing us just to get so much more depth. I mean, he talked about metabolic resilience, and this might seem kind of like a passive video, but it's really not. This is a big thing. These are things that will affect Mayo Clinic, that will affect how we're viewing medicine. And there's much more to be found here. But at any rate, we are doing this early launch period for the microbiome panel, which will include metabolic resilience, and I'll share a little bit more about it. But it's only for 5 clinics. And we do need to qualify you. So we are accepting applicants at this time. I anticipate to have over 100 applicants for this. And from that, we will be accepting 5 clinics to do this early launch with us. Just keep in mind, this is not the least expensive test on the market. We are not cost competitive because we have so much more quality, so much more science, so much more that we're doing to support the clinicians in this. So you can expect to get 10 test kits. It's going to be around $6,000, and that's the cost. But if you are interested in applying for this, let me tell you a little bit about it. So we're giving the deepest resolution possible for a microbiome test. So you might have seen 16S sequencing, other microbiome analysis out there that really just don't give you the deep understanding of the microbiome. So for example, an individual can have salmonella, and if you're looking at the species level, it can be a lot of different forms of salmonella. It could be when you get down to the strain level, you might understand that it's a really insidious form that you need to take care of, or it's something that just doesn't have a huge effect on them. And so that strain level understanding really allows us to understand the microbiome from a totally new level, allowing the deep targeting of that. So if you've seen some of the videos with Dr. Moore, really interesting concept that once we get down to the strain level, that's really where the money is at. That's really where you can get the results, because you might be applying the totally wrong thing based on the species when you're not even looking at the strain. But in addition to that, we have AI-driven analysis and digital twinning. So we're using really advanced AI algorithms to create the digital twin of the individual. So we're creating that digital replica, and then we're simulating the effects of all these different interventions to find what interventions are going to be the most effective. So we automatically create precision and personalized protocols for you, the practitioner. Then you can filter your understanding of the patient history, your clinical judgment, and come up with a protocol that you think is going to be best. But we take a lot of the legwork out because, like I said, we're simulating the effects of thousands of interventions, finding out what we believe is going to be the best for this individual. So as far as what you will find inside this microbiome report, you will find an antibiotic resistance analysis where you'll be able to identify antibiotic resistant genes present in the microbiome, which is crucial for understanding potential resistance issues and informing appropriate treatment options. There will be a pathogen and parasite panel. There will be a probiotic panel. There will be a food intolerance analysis. There will be inflammation markers. And then, of course, there's going to be just key gut health metrics such as stability, diversity, balance, digestion, and gut barrier. These things will all be evaluated. So if you are interested in applying for this and potentially being a part of the 5-clinic cohort that's going to be doing the early launch on this, I have the link down below this video where you can go and initiate the application process. So all it is you sign up for a 15-minute phone call. We have some questions that we walk through, and then we're going to take our applicants and choose 5 in the next 2 weeks. So if that's something that's appealing to you, go ahead and click the link that you see below this video and get started. Dr. Jasbi, again, thank you so much. Really informative on metabolic resilience and understanding how this is going to impact medicine and how this currently impacts people that might be in a health state or a disease state.
Thanks, Micah.